Because of the recent disaster in Fukushima, Japan, nuclear safety has been thrust into the spotlight.
So we, you're not quite nuclear experts, are here to explain nuclear power to you with the help of a true nuclear expert. Let's cut to John in the field.
Thanks, Cameron. I'm John, and I'm in the field. Now to Matt Hackney with some information on the future of nuclear power.
I'm currently a engineering manager for the Waste Solidification Building Project. We're building a $420 million facility to treat primarily americium, waste byproduct of producing plutonium oxide, mixed oxide fuel for creation of nuclear power. The project is currently in progress, and we're at about 95% complete. My past experience includes a stint as a reactor control room supervisor, a heavy water moderated reactor at the Savannah River site. I think the most encouraging thing that's going on right now is the realization that fossil fuels, while they're necessary at this time, aren't the long-term solution. There's been a tremendous amount of development around the world in nuclear power and development of nuclear energy. And there are a tremendous number of new technologies available for encapsulating the nuclear material, ensuring that it doesn't pose a risk of a Chernobyl or type meltdown or a leak of the type that occurred in Japan recently.
A nuclear accident is any unintended event, including operating errors, equipment failures, and other mishaps, the consequences or potential consequences of which are not negligible from the point of view of protection or safety, according to the International Atomic Energy Agency. So, John, how do these accidents happen?
Well, they could occur in a variety of ways. One cause could be a nuclear meltdown. This could happen if a power plant loses its coolant, which causes the temperature to rise drastically.
Once the temperature has risen, the hot uranium fuel rods would melt and seep into the ground, about 50 feet. There, it mixes with groundwater and causes large explosions of radioactive steam. These explosions affect a large area around the power plant.
Cameron,
Yeah?
does that mean we could have another Godzilla?
Not quite, but it could affect other populations depending on proximity to the plant.
Okay. According to BP Energy Outlook 2035, the demand for power increases 2% annually. To meet this demand, more nuclear power plants are being built every year. Cameco is projecting 97 new power plants to be built by 2020.
The more power plants you have, the higher the risk of a nuclear accident happening.
The radiation from these potential accidents could cause mutations in the genetic code, which could greatly damage an organism and especially its offspring. But when did this all start?
Get ready to go through a journey through time.
It's 1939 and scientists just discovered that through atomic fission, energy could be created.
It's 1942, and the first controlled, self-sustaining nuclear chain reaction was just created.
It's 1946 and the US Congress passes the Atomic Energy Act to establish the Atomic Energy Commission. The commission is charged with overseeing the use of nuclear technology in the post-war era.
It's 1951, and the experimental breeder Reactor 1 at the Idaho National Engineering and Environmental Laboratory produces the world's first usable amount of electricity from nuclear energy.
It's 1954 and the US Congress passes the Atomic Energy Act of, you guessed it, 1954, amending the 1946 Act to allow the Atomic Energy Commission to license private companies to use nuclear materials and also to build and operate nuclear power plants.
It's 1979, and the nuclear facility at 3 Mile Island near Harrisburg, Pennsylvania, experiences a major failure. Although little radioactive material escaped, it did bring into question the safety of nuclear energy to the general public.
It's 1986, and the Chernobyl power plant in the Soviet Union has just melted down. This released massive amounts of radiation into the atmosphere over Europe.
From this history, the United States has developed the strictest safety measures for control of nuclear power.
Although policies are very strict in the United States, other countries have had problems with nuclear power. Asia, and Japan in particular, have had multiple nuclear accidents.
This could be caused by the density of nuclear reactors in Japan, which is 12 times the density of reactors in the United States.
The main problem is cooling. This problem is encountered with fossil fuel plants as well, but with nuclear plants, the problem continues after the fission is stopped. So, power plants use one of three techniques. They can either have direct cooling if they are near a large body of water. In this way, they pull a large amount of water once through the cooling circuit, it cools the plant, and then is returned to the body of water only slightly warmer.
Another solution is recirculating cooling, in which the water is circulated through the cooling circuit several times and use wind to again cool the water in between circuits. Finally, dry cooling can be used to cool the water without water, similar to a car radiator.
As only 3 major nuclear disasters have occurred, it is safe to say that the solutions are working relatively well. However, the price of an accident is so great that a 100% clean record is the goal.
One problem with direct cooling, the simplest way to cool the reactor, is that aquatic animals can be drawn into the intake system. Also, the increase in water temperature can kill fish, which may destroy the ecosystem.
Some newer models of cooling systems can cool the reactor even when it is not running. However, they still pose the same environmental hazards as the newer models.
Let's cut to Matt Hackney for some more information on cooling systems.
There are a number of different ideas, technologies in progress. Many people are familiar with the sodium-cooled reactor, and that was basically a direct cooled but with an isolation loop. The reactor that I was involved with was actually a very primitive 1950s era primary-secondary cooling system design that included a heavy water moderator that was also the primary coolant. Today they're using pebble bed technologies, which are basically an air-cooled system. They're also using some that are small, they call them a small modular reactor that use direct cooling and actually conductive cooling. And those reactors they're planning are very small in nature, they're almost portable, they're built in a factory and placed at a site. And those are in development today by the Department of Energy. And finally, there is a resurgence in the design and construction of more traditional reactors, boiling water reactors, and also pressurized water reactors. And those designs are based on the AP 2000 design that was an outgrowth of an effort by Westinghouse in the 1990s. And those are direct licensed for construction and operation. And those are the first generation you'll see put in operation. The first of those is Plant Vogtle in Georgia, and there's a second, there are 2 units there, and 2 more units being built at Virgil Sumner in South Carolina. And while those are the near-term, long-term, the pebble bed and the small modular reactor appear to have the best outlook for the future.
Fantastic, thank you. I appreciate your time, Matt. This is Craig Stevens with Nuclear News. Back to you, John.
So in summary, although Godzilla is not a threat, nuclear accidents are a very serious issue.
Nuclear power seems to be the cleanest form of generating electricity. However, policies and protocol must be in place to keep accidents from happening, and the utmost care must be taken while working with nuclear power.
If this happens, nuclear power can be the future for our world.